Are there nuclear reactions going on in our bodies? Yes, there are nuclear reactions constantly occurring in our bodies, but there are very few of them compared to chemical reactions, and they do not affect our bodies much. All physical objects are made of molecules. A molecule is a series of atoms linked together by chemical, electromagnetic bonds. Inside each atom is a nucleus, which is a collection of protons and neutrons linked together by nuclear bonds. Chemical reactions are the making, breaking, and rearranging of bonds between atoms in molecules. Chemical reactions do not change the nuclear structure of any atoms. In contrast, nuclear reactions involve the transformation of atomic nuclei. Most of the processes surrounding us in our daily lives are chemical reactions and not nuclear reactions. All of the physical processes that take place to keep a human body running, blood capturing oxygen, sugars being burned, DNA being constructed, etc., are chemical processes and not nuclear processes. Nuclear reactions do indeed occur in the human body, but the body does not use them. Nuclear reactions can lead to chemical damage, which the body may notice and try to fix. There are three main types of nuclear reactions. Nuclear fusion. This is the joining of two small atomic nuclei into one nucleus. Nuclear fission. This is the splitting of one large atomic nucleus into smaller fragments. Radioactive decay. This is the change of a less stable nucleus to a more stable nucleus. Note that nuclear fission and radioactive decay overlap a little bit. Some types of radioactive decay involve the spitting out of nuclear fragments and could therefore be seen as a type of fission. For this article, fission refers to large-scale nucleus fragmentation events that cannot be classified as radioactive decay. Nuclear fusion requires high energy to be ignited. For this reason, nuclear fusion only occurs in stars, in supernovas, in nuclear fusion bombs, in nuclear fusion experimental reactors, in cosmic ray impacts, and in particle accelerators. Similarly, nuclear fission requires high energy or a large mass of heavy, radioactive elements. For this reason, significant nuclear fission only occurs in supernovas, nuclear fission bombs, nuclear fission reactors, cosmic ray impacts, particle accelerators, and a few natural ore deposits. In contrast, radioactive decay happens automatically to unstable nuclei and is therefore much more common. Every atom has either a stable nucleus or an unstable nucleus, depending on how big it is and on the ratio of protons to neutrons. Nuclei with too many neutrons, too few neutrons, or that are simply too big are unstable. They eventually transformed into a stable form through radioactive decay. Wherever there are atoms with unstable nuclei, radioactive atoms, nuclear reactions occur naturally. The interesting thing is that there are small amounts of radioactive atoms everywhere. In your chair, in the ground, in the food you eat, and yes, in your body.